Hello viewers, welcome back to class. I'm super excited to have you guys back to class again. You are welcome to Master Builders Online Academy. Don't forget to subscribe to this YouTube channel if you have not done so, or maybe you are visiting this page for the very first time. And also, don't forget to turn on the post notification bell so that anytime we upload mind-blowing content, you will be notified. Guys, we have policy that we strictly follow here on our channel. One of the policies is that anytime you are set to watch this video, don't entertain any form of distraction. Ensure that you enjoy maximum focus so that you will be able to understand everything that we teach here. And also, don't forget, do not skip any part of this video. It is for your own good. Do not skip any part of this video because you may skip a very important aspect of this training that would have given you all that you need to know this topic. And that's the reason why we advise. Do not skip any part of this video. Finally, if there be any part of this video you do not understand, maybe when you watch it for the very first time, or you watch it and you do not understand, maybe when you watch it for the very first time you do not understand, please, you have the singular opportunity to replay the video over and over again until you understand that part that is giving you issues. And also, if after you have watched it over and over again, you still have not been able to get the concept, then you can slide down to the comment section and make your necessary comments. We will attend to every comment that you document at the comment section. Alright, so if this is taken, let's get to work. On the board, we have second order differential equation. So for quite a number of time now, in our previous lessons, we have looked at differential equation. And we said that under differential equations, we have what we call orders of differential equation, where we have first order, second order, third order, and nth orders. Are you there? Now, you remember vividly, for those that have been following us, that we have looked at first order differential equation, and we have provided necessary solutions to any form of first order differential equation that you can be given. Now, in this tutorial or in this lesson, we are going to be looking at solutions to second order differential equation. Now, if you are new in this page, understand that this is how you know first order differential equation. Any equation that you are given that contains just dy over dx, it means that you are dealing with first order differential equation. And of course, we have 5 methods or approaches for solving problems on first order differential equation. So you can go to the playlist of our channel where you can find differential equation under first order differential equation. If that is understood, for second order differential equation, we have this as the leading derivative. Are you there? So how do I know that I'm dealing with second order differential derivative or I'm dealing with second order differential equation? The equation must contain this second order derivative. So for first order differential equation, the leading derivative is what? First derivative. For second order differential equation, the leading derivative is this square y over dx square. So any equation that contains this function or this derivative is a second order differential equations. Are you there? So now, in second order differential equation, there is a particular standard of equation that we are being given. Alright? Now, when we look at the board, we'll see that the second order differential equation is of the form a d square y over dx square plus b dy over dx plus cy is equal to f of x, where a, b, and c are constants or integers, numerals, coefficients. Are you there? Where and f of x is a function of x, which we have at the right hand side of the equation. Now listen carefully. This second order differential equation is controlled by 2 factors. Hence, we label it to be case 1 and case 2. And what are these factors? What influences these cases is what we have at the right hand side of the equation. So for this function of x, we just have as f of x, it can be a constant. When I mean a constant, it can be 24. This is a constant. It can be, that function can be what? Linear equation. The function can be quadratic equation. It can be polynomial equation. Alright? N, where n is greater than 2. Then it can be what? Trigonometrical equation. Alright? Function. It can be hyperbolic function. Sine 24x. It can be exponential function. It can be logarithmic function. Alright? This f of x can be any of the mathematical function. And equally, it can be 0. Alright? So these are the things you need to know. So what actually influences the case to which any second order differential equation belongs is what you have at the right hand side of the equation. Now, let's get to work. What to do now is to take the very first case. Now, the first case, case 1, is when f of x is equal to 0, which is exactly as what? A homogeneous equation. Are we there? The first case, like I said, we have two cases. Now, case 2 is when f of x is equal to what? Any function of x. For case 1, so these are the two cases that we are going to be looking at when dealing with second order differential equation. So we have case 1, we have case 2. Now we are going to start from the very first case, which is case 1. Now we take case 1. When f of x is equal to 0. So if f of x is equal to 0, now this equation now becomes a d square y over the s squared plus b dy over dx plus cy is equal to 0. So this standard equation now has changed to this particular equation where f of x is equal to 0. Now when you have this case, what you simply do is to convert this second order differential equation to its auxiliary equation. And how do you get this done? Now understand that to convert any second order differential equation to its auxiliary equation where the right hand side is equal to 0, all you simply do is to have that d square y over the s squared is equal to m squared. Then dy over dx is equal to m, then y is equal to 1. This is it. So to convert any second order differential equation to its auxiliary equation that will enable us to be, that will help us to solve this equation effectively, all we simply do is to change this square y over the x squared to m squared, change the y over the x to m, and change y to be what? 1. So what do we do? When we come here, this will have given us a multiplied m squared plus b multiplied m. We are substituting for this guy and this other guy. Then plus c multiplied by 1 is equated to 0. And at this point, when we multiply out, this will have given us a m squared plus b m plus c is equal to 0. Now this is the auxiliary equation for every second order differential equation question that you'll be given. The first thing you must always do is to convert the left hand side of the equation to its auxiliary equation. And to have this done, you must ensure that the right hand side of the equation is already equated to 0. Now if this is understood, from this expression we just have now, we discover that this is a quadratic expression because we said earlier that a, b, c are constant. That means we have m to degree 2 and m to degree 1, then we have a constant. It shows that this is a quadratic expression. And for every quadratic expression, you will have two roots, which are two answers. Are you there? There is no way you will solve any two quadratic equation without having two roots. Okay? So therefore, we have two roots to this equation. Now, what would have become the general solution to this equation? So the general solution to this equation would have been what? Y is equal to A E M1 plus B E M2 all multiplied by X. So this is the general equation. So what do you need to know here? Here, you need to know that this is equation 1. You also need to know that this is equation 2. Then you need to know that this is equation 3. So these are the basic three equations that you need anytime you want to solve problems on the first, second order differential equation when the right hand side of the equation or f of x is equated to be 0. So these are the equations you need. Of course, equation 1 is the equation that you are given by the examiner. Are you there? While equation 2 is what you will deduce, the first step you will take, that you will deduce from the given equation. While equation 3 is the final solution to the results that we have here. So m1 is root 1, because for quadratic equation we have two roots, and m2 is root 2. Then a and b, they are what? Arbitrary constants. Just like when we are dealing with first order differential equation, after we have integrated the function, we always add k as an arbitrary constant. The same thing happens here. So this a and this b came as a result of integration. So where a and b are arbitrary constants. Alright? So A and B are arbitrary constants. So guys, what do I need to do, or what do I need to know to be able to solve second order differential equations effectively under case 1? One is to note the given equation, ensure that it is already equated to 0. 2 is to deduce the auxiliary equation, where you change this to this, change this to this, and change this to this. Then you have this equation, which happens to be equation 2. Then from here, you will now solve equation 2 quadratically. And you understand that to solve quadratic equation, there are several methods. I think we have about 4 methods. You can use factorization method. You can use formula method. You can use method of completing the square, and you can also use the graphical method. These 4 methods, any of the methods you like best. Of course, nobody will state the method you have to use, so you make use of any method of your choice. But sometimes you do not make use of any method of your choice because not all quadratic equations are factorizable. So when you have a case that you cannot factorize, then you can switch to any other method, alright? But it is easier to use factorization method. But for functions or equations that are not factorizable, you will now have to take another choice. So if this is understood, the next thing we are quickly going to do now is to know how this equation came into being. How was this equation derived or deduced from this general equation? This is what will be our next class. Alright? So we are going to be examining this equation. How come about equation 2 from this equation 1, and how do we get equation 3 from equation 2? Like I explained earlier, we obtain equation 2 from equation 1, and equation 1 is the given equation. Alright? So how did we obtain this from this? And how did we now obtain this from this other guy? So we are going to be looking at this in the next class. So see you guys. Don't forget to subscribe to this YouTube channel if you have not done so. And ensure that you turn on the post notification bell so that anytime we release mind-blowing content, you will be notified, even while you are asleep or if at the reading table. So guys, see you guys in the next class.